Hello students, happy morning. Class 12 Physics, Unit 6 Ray Optics continuation video. From today's class onwards, let's start our next phenomenon of light in ray optics, that is refraction. Okay, refraction is nothing but the bending of light. Refraction is nothing but a bending of light. Okay, refraction is defined as a light passing from one optical medium to another optical medium through a boundary. Okay, see, refraction is defined as a passing of light from one optical medium to another optical medium through a boundary. Through the boundary is called refraction. Okay, first of all, I consider a boundary that separate two layers. One is air medium, another one is water medium. Okay, here the air having the refractive index n1 and the water having the refractive index n2. Here we know refractive index of water is greater than refractive index of air. Air is a rarer medium, water is a denser medium. Okay, here there is a ray of light that is named as AO, that instant on the point. Here I drawn a normal, then after that it will refract or bend towards a normal. Okay, see, this ray is known as refracted ray. OB is a refracted ray. AO is an instant ray. It fall on the boundary. After that it will bend its path in the second medium, that is OB. It bend towards normal because the ray of light come from rarer medium to denser medium. For this case, the light will bend towards the normal. Okay, here the angle between the instant ray and the normal, that is known as angle of incident psi, and the angle between the refracted ray and the normal is known as angle of refraction R. Okay, here for this case the light come from rarer to denser medium. Okay, if suppose here it is a water, here it is air, reference index is considered as n1, here n2. n1 is greater than n2, that means light come from denser to rarer medium. Okay, this is a point of instant. At that point I drawn a normal. Okay, after the instant it will refract its path away from the normal. Okay, because the light travel from denser to rarer medium. This is angle of instance, this is angle of refraction. Okay, then there will be a two laws for the refraction. Okay, that is named as law of refraction. Law of refraction, that is also named as Snell's law. First law, the incident ray refracted ray and the normal all lie in a same plane. Okay, see, the instant ray, refracted ray and the normal all lie in a plane of the paper. Okay, that is all lie in a same plane. Then second law, that is easy one. Sin I by sin R is equal to n2 by n1. Okay, it is a ratio of sine of angle of incidence to the sine of angle of refraction is equal to ratio of refractive index of the second medium to the refractive index of the first medium. Okay, that is a easy one. Here this one is in ratio form. In order to write in a product form, cross multiply it. Okay, n1 sin I is equal to n2 sin r. This is a product form of Snell's law. Okay. See, first law, the instant ray, refracted ray and the normal all lie in a same plane. And the second law, that is sin I by sin r is equal to n2 by n1. Okay. Here it is a ratio of sin of angle of incidence to the sin of angle of refraction, that is equal to ratio of refractive index of the second medium to the refractive index of the first medium. Okay. Then our next topic is angle of deviation due to refraction. Then angle of deviation due to refraction. Okay. Here angle of deviation is an angle between the instant and the deviated light ray. Okay. Whatever we discussed in the reflection phenomena. Okay. See, angle of deviation. First of all, I consider a boundary. This boundary separate two layer. One is the rarer medium, one is the denser medium. Okay. Here it is a refractant index n1, it is refractant index n2. We know n2 is greater than n1. Then next, there is a ray of light that fall on the point O. At that point, I considered a normal. Okay. Here the ray of light come from rarer to denser medium, so it will bend towards the normal. Okay. A, O, this is O, B. Then we know this is R. We know very well angle of deviation is a angle between the instant ray and the deviated light ray. Here it is a extended instant ray. Okay. If there is no boundary here, it will come in this direction alone. Okay. Because of another optical medium, it deviate its path in this way. Okay. So this is a deviated ray, this is a instant ray. Angle between the instant and deviated light ray is known as angle of deviation. This is named as D. So we can write D as, okay, this is vertical opposite angles. Overall value is vertical opposite angle. So we can write this one as I. Overall value is I. So we can write D is equal to I minus R. For the case the light come from rarer to denser medium. Okay. If suppose the light come from denser to rarer medium, here it is n1, it is n2, n1 is greater than n2. Okay. For that case, here it is a normal. Okay. Ray of light coming in this direction. That instant on the point O, here it come from denser to rarer medium, so it will bend away from the normal. Okay. Its actual path is this one only. It will bend away from the normal. This is the angle of deviation. So we can write this is I. Okay. This also I. This is I. So we can write this one. This entire value will be, this is D. This value will be R. Okay. This is angle of refraction. So we can write D as D is equal to R minus I. See, if ray of light come from rarer to denser medium, the angle of deviation will be D is equal to I minus R. Ray of light come from denser to rarer medium, angle of deviation will be R minus I. Okay. Our next topic, that is simultaneous reflection and refraction. See, we have to know that for every refracting surface there will be also some reflection. Okay. எங்கெங்கெல்லாம் reflection நடக்குதோ கண்டிப்பாக அங்கே என்ன நடக்கும், refraction நடக்கும். எங்கெல்லாம் refraction நடக்குதோ கண்டிப்பாக அங்கே நடக்கும், reflection நடக்கும். ஓகேவா? See, first of all I consider a refracting surface. For every refracting surface there will be also some reflection take place. Okay. Here I consider a refracting surface. Here there is an instant light. It is a normal. I consider this one is air medium. This one is water medium. So it will bend towards a normal. Okay, instant light, refracted light. Here there is also some reflection is there. Okay, this is I, this also I. We know according to the law of reflection, instant angle is equal to reflected angle. Okay, this is angle of refraction R. Okay, instant ray, refracted ray. This is reflected ray. This is normal. Here the phenomenon of which the part of light from the source, okay, that undergo reflection, and the other part of the light that undergo refraction, that is known as simultaneous refraction or simultaneous reflection. Okay, at the same instant it undergo reflection as well as refraction, that is known as simultaneous reflection or refraction. For example, partially silvered glass. This may allow the light and also it will reflect the light. Okay, the next concept, principle of reversibility. Okay, here it states that the light will follow exactly same path if the direction of travel is reversed. Okay, it states that light will follow exactly same path if its direction of travel is reversed. Okay, see, it states that the light will follow exactly same path if the direction of travel is reversed. If suppose I consider a reflecting surface, here it is a reflecting surface, there is a ray that instant on the reflecting surface. Okay, after reflection, after that instant it will reflect, its path will be here. This is angle of instance, this angle of reflection, that also I. Okay, at that reflected path I am placing a mirror, then the mirror reflect its reflected ray, then it will instant on the point O and also it will reflect in this direction alone. Okay, see, here the light will follow the same path whatever it went. Okay, when the direction of travel is reversed, it is for a reflection. It also for it will obey also for the refraction also. Okay, here I consider a boundary that separate two layers, one is rarer medium, another one is denser medium. Okay, there is a ray of light, here I draw a normal, then it will bend towards a normal. Okay, at that point I am placing the mirror. Here it will reflect and it will retrace its path whatever it came. Okay, it retrace its path whatever it come. This is for refraction. Here the principle of reversibility hold true both for reflection and refraction also. Okay, then our next concept, that is relative refractive index. Relative refractive index, that is n2 by n1. It is a relative refractive index of the second medium with respect to the first medium. Index of the second medium with respect to first medium. Okay, we can write this one as n21 is equal to n2 by n1. Okay, we can use it for two rules, that is inverse rule and chain rule. Inverse rule, if suppose n12 can be written as 1 by n21, we can write this one as n2 by n1. Okay, this is inverse rule. One more rule is there, that is chain rule. Okay, that is n32 can be written as n31 into n12. We can write n31 as n3 by n1 and this one as n1 by n2. We can combine it as n31 into n12. Okay.